السلام عليكم ورحمة الله وبركاته. اليوم طلبتنا حنبدي مع الجزء الثاني من المحاضرة الأولى بالأورال سيرجري، وإحنا تركنا الكلام بالمحاضرة السابقة إلى أن وصلنا إلى electrochemistry of the nerve conduction. The concentration of electrolytes in the exoplasm, the interior of the nerve cell, and the extracellular fluids. هنا نريد نناقش كيميائية انتقال الإيعاز العصبي عند الألم، وهي كالتالي. The preceding sequence of events depends on two important factors. أولاً, the concentration of electrolytes in the exoplasm, the interior part of the nerve cell, and the extracellular fluid. والعامل الثاني هو the permeability of the nerve membrane to sodium and potassium entrance and exit through the nerve membrane. ما يحدث بالحقيقة أنه المؤثر أو المؤثر للألم، سبب الألم كان يكون pathology or trauma or thermal stimulus. A stimulus excites the nerve, leading to the following sequence of events. An initial phase of slow depolarization، اختلاف بتراكيز الأيونات في الداخل والخارج للنيرف ممبرين. A stimulus excites the nerve, leading to the following sequence of events. An initial phase of slow depolarization, and the electrical potential within the nerve becomes slightly less negative. B, when the falling electrical potential reaches a critical level, an extremely rapid phase of depolarization results, and this is termed as a threshold potential or the firing threshold، اللي هو بداية الإحساس وأول انتقال للإيعاز العصبي للإحساس بالألم. So يصير عندنا depolarization، أي تغيير بعملية الخروج والدخول للأيونات through the nerve fiber. Step 2, after these steps of depolarization, a repolarization phase will happen. The electrical potential gradually becomes more negative inside the nerve cell، اللي هو الوضع الطبيعي relative to the outside, until the original resting potential حدود minus 70 millivolt is again achieved. The process in general, the entire process, step 1 and 2, requires about 1 millisecond of depolarization phase، ياخذ حدود 0.3 millisecond، والrepolarization phase ياخذ about 0.7 milliseconds. رجعنا الآن، هذا احنا الشرح الخطوط العامة. نرجع، احنا قلنا كما في الصفحة رقم 11 إنه the cell is surrounded by a semi-permeable membrane which is permeable to water, and a selective ion pump actively pumps potassium into the inner part of the cell and sodium ions out of the cell. The cytoplasm of the cell is negatively charged بسبب وجود البروتينات الموجودة فيه. الريستنج ستيت، حنرجع نتكلم عن الوضع الطبيعي للخلية أو للنيرف فايبر. In its resting state, the nerve membrane is semi-permeable or slightly permeable to the entrance of sodium, freely permeable to potassium ions, and the potassium ions remain within the exoplasm despite its ability to diffuse freely through the nerve membrane. and its concentration gradient, passive diffusion usually occurs from the region of the greater concentration to one of the lesser concentration. And because of the negative charge of the nerve membrane, restrains the positively charged ions by electrostatic attraction. The sodium migrates inwardly because both the concentration greater outside and the only fact that the resting nerve membrane is relatively impermeable to sodium prevents a massive influx of this ion. الفكرة إنه it is partly semi-permeable to the entrance of sodium ions to the interior of the exoplasm. الغاية حتى يصير الإعازة العصبي لازم it becomes permeable to the entrance of sodium ions. واللي هو هذا ما يحدث بالdepolarization, first phase. So membrane excitation, electrochemistry of the nerve conduction. أول شيء يصير عندنا depolarization اللي هو greater influx of sodium to the inside of the cell membrane. Excitation of a nerve segment leads to an increase in permeability of the cell membrane to sodium ions. And this is accomplished by a transient widening of the transmembrane ion channels, sufficient to permit the unhindered passage of hydrated sodium ions. The rapid influx of sodium ions to the interior of the nerve cell causes what happened in the depolarization of the nerve membrane, forms its resting level to its firing threshold approximately 50 إلى 60 millivolt. The firing threshold is actually the magnitude of the decrease in the negative transmembrane potential that is necessary to initiate an action potential or an impulse. دخل الصوديوم ions to the inside of the cell membrane. واللي هو هذا ما موضحه بهذا المخطط. هاي السيجمنتس الوردية هي تمثل ال channels for the entrance of sodium ions. So the sodium channel transition stages. Depolarization reverses the resting membrane potential from the interior, which is negative, to the center. يصير عندنا دخول لأيونات الصوديوم, and the channel proteins undergo corresponding conformational changes from the resting state, ويعقبها a repolarization state اللي هو يرجع إلى سابق عادة إنه الصوديوم ions are great out of the cell membrane والpotassium ions are great in the interior of the cell membrane. Repolarization, the action potential is terminated when the membrane repolarizes, and this is caused by the inactivation of increased permeability to sodium. In many cells, permeability to potassium also increases, resulting in the influx of potassium ions and leading to more rapid membrane repolarization and return to its resting potential. دائما المحاولة هي أنه يرجع إلى وضعية الرستنج بوتنشيال، لكن بوجود الستيمولس المحفز للألم يظهر عندنا حالة الديبولاريزيشن. لكن هي ما نحس احنا بذهاب الألم أو هذا الترانزيانت ريبولاريزيشن ما نحس به، لأنه ده يحدث بفترة قصيرة جدا جدا اللي هي about 1 ملي سكند، يعني أجزاء الثانية 1% من أجزاء الثانية. الامبلس بروباجيشن، استلم النيرف فايبر، استلم الإعاز العصبي أو استلم المحفز للألم، استلمه. After initiation of action potential by a stimulus, the impulse must move along the surface of the axon and the energy for the impulse propagation تسارع الإعاز العصبي is derived from the nerve membrane in the following manner. The stimulus disrupts the resting equilibrium of the nerve membrane, with the interior of the cell changing from negative to positive and the exterior changing from positive to negative. This new electrical equilibrium in this segment of nerve produces local currents that begin to flow between the depolarized segment and the adjacent resting areas. هذا الاختلاف الأيوني اللي يصير حيسوي لنا electrical charging حتى يدفع بالإعاز العصبي باتجاه CNS. These local currents flow from positive to negative, extending for several millimeters along the nerve membrane. As a result of this current flow, the interior of the adjacent area becomes less negative and exterior less positive, and the transmembrane potential decreases, approaching firing threshold for the depolarization. Impulse, conduction, and transfer. Once a stimulus is converted to an action potential, يتحول إلى إعاز كهربائي, the action potential must be propagated along the nerve, and this occurs as a sequential depolarization along the membrane. كل membrane من segment إلى segment حيصير بها نفس اللي صار بأول استلام لمحفز الألم اللي هي depolarization and repolarization حتى ينتقل هذا الإعاز العصبي along the nerve fiber. In myelinated nerve fiber, the sodium channels are only present in the gaps اللي هي node of Ranvier. That's why لهذا الاختلاف اللي قلناه مثل ما قالوا بعض زملائكم حيكون نقل الإعاز العصبي jumping or saltatory conduction, while in the unmyelinated nerve fibers the conduction is a continuous process ينتقل along the nerve fiber itself. Nociception in the orofacial pain. The process of transduction, transmission, modulation, and the perception are also occur in the head and neck area, of course. Tooth pain caused by stimulation of the nociceptors in dental pulp that respond to mechanical and thermal activation. The intensity of the pain is determined by the frequency of the sensory stimulation and by the number of nerve fibers that are excited. Temperature stimulation induce immediate pain response through a fiber, اللي هي myelinated nerve fiber. Electrical stimulation induces ion transport, resulting in the stimulation of nerve endings. The same process occurs in osmotic stimulation مثل ما التحسس مثل for example sugar and salt تحسس للسكريات. Chemical inflammatory mediators cause the stimulation of nociceptors in the C fibers in the pulp in the unmyelinated nerve fiber. In painful teeth, the concentration of these inflammatory mediators is increased. They are released from the nerve fiber endings during the stimulation and activate nociceptors. How local anesthesia work, or how local anesthetics work? The primary action of local anesthetics in producing a conduction block is to increase the permeability of the ion channels to sodium ions. Local anesthetics selectively inhibit the peak permeability of sodium, whose value is normally about 5 to 6 times greater than the minimum necessary for impulse conduction. Local anesthetics reduce this safety factor, decreasing both the rate of the rise of the action potential of its conduction velocity. Local anesthetics produce a very slight, virtually insignificant decrease in potassium conductance through the nerve membrane. Calcium ions, which exist in bound form with the cell membrane, are thought to exert a regularity rule on the movement of sodium ions across the nerve membrane. وهاي النقطة مهمة جدا. الكالسيوم ions, which exist in bound form within the cell membrane, are thought to exert a regularity rule on the movement of sodium ions across the nerve membrane. Release of bound calcium ions from the ion channel receptor sites may be the primary factor responsible for increased sodium permeability of the nerve membrane. هاي هنا صور توضح الساينابس between the nerve ending and the effector organ. الآن حنتعرف على الثيوريز اللي تشرح لنا كيف يعمل اللوكال انستيزيا. هي لا زالت ثيوريز كلها خلينا نقول ماكو في شيء مثبت 100% كيف يعمل اللوكال انستيزيا. مجرد هي نظريات. اكو بعض واحدة من هاي النظريات اللي نعتمد عليها اللي نفسر بيها كيفية عمل اللوكال انستيزيا. المود and site of action of local anesthetics. How and where local anesthetics alter the process of impulse generation and the transmission needs to be discussed. It is possible for local anesthetics to interfere with the excitation process in the nerve membrane in one or more of the following ways. Altering the basic resting potential of the nerve membrane. هاي عبارة عن شرح إلى كيفية عمل اللوكال أنستيزيا. إما يسوون altering بالbasic resting potential of the nerve membrane or altering the threshold potential, الfiring level، يصعد الليفل بالشعور بالألم لأول وهلة، decreasing the rate of depolarization or prolonging the rate of repolarization. فإحنا حتى نخليه اللوكال أنستيزيا يشتغل هو إما نسوي اختلال بالresting potential of the nerve membrane or نرفع عتبة الألم البين threshold، نرفعها حتى نقلل الإحساس لدى المراجع، أو decreasing the depolarization rate، depolarization time نقلله بعد أكثر حتى لا يصل الألم أو شعور الألم يكون لوقت قليل جدا جدا، or prolonging the resting potential resting أو the rate of repolarization. طالما أكو repolarization اللي هو resting potential فبالتالي ما حيكون عندنا شعور بالألم. It has been established that the primary effects of local anesthetics occur during depolarization phase of the action potential, and these effects include a decrease in the rate of depolarization. Because of this, cellular depolarization is not sufficient to reduce the membrane potential of the nerve fiber to its firing level, and a propagated action potential does not develop. Theories of local anesthetics. الحقيقة عندنا 4 نظريات تتحدث عن كيف يعمل اللوكال أنستيزيا. النظرية الأولى اللي هي الأسيتايل كولين ثيوري. Acetyl choline theory stated that acetylcholine was involved in the nerve conduction in addition to its role as a neurotransmitter at nerve synapses. There is no evidence that acetylcholine is involved in the neural transmission along the body of the neuron. Calcium displacement theory, هاي النظرية الثانية, states that local anesthetic nerve block was produced by displacement of calcium from some membrane site that control permeability of the sodium, altering the concentration of calcium ions has no effect on local anesthetic activity. إذن هاي نظرتين كانت مطروحة ولكن تم دحضها هاي النظريتين اللي هي الأسيتايل كولين ثيوري والكالسيوم displacement theory. These two theories, membrane expansion and specific receptor, are given a credence today. النظريتين التالية اللي هي الممبرين اكسبانشن ثيوري والسبيسيفيك ريسبتور ثيوري هي تقريبا المعمول بها أو اللي تفسر the action of local anesthesia. النظرية رقم 3 اللي هي الأولى المعمول بها the membrane expansion theory states that local anesthetic molecules diffuse to regions of excitable membrane, producing a general disturbance of the bulk membrane structure, expanding some critical regions in the membrane, and preventing an increase in permeability to sodium ions. Local anesthetics that are highly lipid soluble can easily penetrate the lipid portion of the cell membrane, producing a change in the configuration of the lipoprotein matrix of the nerve membrane. This results in a decrease in the diameter of sodium channels, which leads to inhibition of both sodium conductance and neural excitation. إذن هاي النظرية إنه يقول لك local anesthesia حيسوي لنا تضيق بالchannels regions المختصة بدخول الصوديوم ايونز، فلذلك بهالحالة ما حيصير عندنا عبور للصوديوم ايونز وبالتالي يصير عندنا inhibition of transmission of nerve impulse. النظرية الرابعة اللي هي the specific receptor theory واللي هي تقول the most favored today which is the most favored today يعني أحسن واحدة من هاي النظريات الأربعة هي the specific receptor theory. هذيك النظريتين القديمة اللي أسيتايل كولين ثيوري والكالسيوم displacement theory تقريبا أهملت الآن، لكن اللي يعتمد عليها هي the membrane expansion theory والأكثر which is most favored هي the specific receptor theory. Proposes that local anesthetics act by binding to specific receptor on the sodium channel. The action of the drug is direct, not mediated by change in the general properties of the cell membrane. Both biochemical and electrophysiological studies have indicated that a specific receptor site for local anesthetic exists in sodium channel, either on external surface or on its internal exoplasmic surface. Once the local anesthetic has gained access to the receptor, permeability to the sodium ions is decreased or eliminated and the nerve conduction is interrupted. الفرق بين هاي النظرية والنظرية السابقة، النظرية membrane expansion theory هنا عندنا دي يصير بلوك للباسجز للchannels المتخصصة للصوديوم ايونز by configuring or changing its structure الضيقة. لكن هذا النظرية specific receptor theory اللي يصير عندنا هو chemical interaction. اللوكال انستيزيا دي يسوي بلوك لهاي channels without altering its structure or its morphology by blocking the entrance of the ions, sodium ions, to the inside of the exoplasm. The following sequence is the proposed mechanism of action of local anesthetics. أولاً زي يصير عندنا displacement of calcium ions from sodium channel receptor site, which permits Binding of the local anesthetic molecule to this receptor produces blockade of sodium channel and decrease in sodium conductance, which leads to depression of the rate of electrical depolarization. Failure to achieve threshold potential level along with lack of development of propagated action potential, of course. And this is called conduction blockade. The mechanism whereby sodium ions gain entry to the exoplasm of the nerve, thereby initiating an action potential, is altered by local anesthetics. And the nerve membrane remains in a polarized state because of ionic movement responsible for its action potential is failed to develop. إذا تعرفنا الآن على ما يحدث أثناء الانتقال الإعازي العصبي من تغير كيميائي along the nerve membrane of the axon والنيورون، طبعا of course الدندرايتس أيضا. وتعرفنا على النظريات الأربعة اللي تتحدث عن كيفية عمل اللوكال أنستيزيا. الآن حندخل إلى موضوع آخر هو الفارماكولوجي of local anesthetics. Local anesthetics share several common characteristics in their molecular structure. A lipophilic group can be identified, which determines lipid solubility, and another part contains a hydrophilic group that determines a degree of water solubility. Usually, the lipophilic part of the molecule is an aromatic structure that contains benzene ring, and the hydrophilic part contains a secondary or tertiary amine. Both parts present at the opposite ends of the molecule and are connected by an intermediate section. This intermediate section consists of an ester or an amide group. Ester or an amide group. And a relatively short chain of 4 to 5 carbon atoms. هذا التشكيلة الكيميائية اللي هي واضحة بهذا الدايجرام. نشوف به الليبوفيليك بارت اللي هو الجزء الذي يذوب في الدهون، ونتذكر دائما انه النيرف فايبر هو مادة دهنية، المايلين هو مادة دهنية mostly lipid and protein، لكن هو mostly is lipid. فاحنا محتاجين جزء دهني اللي يذوب بالنيرف فايبر، ومحتاجين جزء water soluble اللي هو يتحول الى جزء ايوني حتى يتدخل لنا وين بالاكشن بوتنشال بالديبولاريزيشن والريبولاريزيشن phases of formation of the nerve impulse and its propagation. So we have two groups of local anesthesia, الأستر جروب والأمايد جروب. وهذا هو الفيجر يوضح لنا الليبوفيليك بارت والهيدروفيليك بارت، وبيناتهم الانترميديت تشين اللي هي إما استر جروب أو أمايد جروب. The ester linkage is more easily broken, so the ester drugs are less stable in solution and are easily hydrolyzed and cannot be stored for a long period of time comparing to the amides. Amide anesthetics are also heat stable, and the metabolism of most esters result in the production of para-aminobenzene, which is associated with allergic reaction, and the amides, in contrast, very rarely cause allergic phenomena or action. For these reasons, amide group are now more commonly used than esters. نوصل إلى الفيزيكال and chemical characteristics of local anesthesia. نتوقف إلى حد هنا ونكمل شرحنا إن شاء الله بالميتينج اللي حتصير يوم الأحد، لأن لازم نشرح هاي الأمور حتى تكون واضحة قبل ما نبدي بالديسوشيشن of local anesthetic agent. شكرا جزيلا وبارك الله بكم.